are here to present our PPT to you all today on the topic Henry's Henry's Law and Rod's Law. So firstly we will discuss about Henry's Law. Henry's Law. This law this law was first formulated in 1803 by English physician and chemist William Henrys. Holds only for dilute solution and low gas pressure. What is Henry's law? Henry was the first to give a quantitative relation between pressure and solubility of a gas in a solvent, which is known as Henry's law. This law states that at the amount of a gas that is dissolved in a liquid is directly proportional to the partial pressure of that gas above the liquid when the temperature is kept constant. The constant of Henry proportionality for this relationship is called Henry's law constant. Henry's law constant. Mathematically, formula of Henry's law is P is equals to Kh dot C. P P denotes the partial pressure of the gas in the atmosphere above the liquid, C denotes the concentration of a dissolved gas, and Kh is the Henry's law constant. The Henry's constant can be expressed in two different ways. If the constant is defined in the terms of solubility per pressure, it is referred to as the Henry's law solubility constant, denoted by H. On the other hand, if the proportionality constant is defined in terms of pressure per solubility, it is called Henry's law volatility constant, denoted by Kh. An illustration detailing the relationship between the solubility of a gas in a liquid and the partial pressure of that gas in the atmosphere above the liquid is provided above. Note that the greater the partial pressure of the gas, the greater its solubility in the gas. As shown in this figure, factor affecting the Henry's law constant. The value of Henry's law constant of a gas is dependent on the following factor: the nature of the gas, the nature of the solvent, temperature, and pressure. Therefore, different gas have different Henry's law constant in different solvents, as illustrated graphically, as shown in this graphical presentation. Limitation of Henry's law. This law is only applicable when the molecules of the system are in a state of equilibrium. Henry's law does not hold true when gases are placed under extremely high pressure. Next, the law is not applicable when the gas and the solution participate in chemical reaction with each other. I call my friend Abhay to continue further.
Rawls law. This law of thermodynamics established by French chemist Francois-Marie Rawls in 1887. Its application of sublimation vapor pressure of mixtures of polycyclic aromatic hydrocarbons. Next. So what is Rawls law? Rawls law states that the solvent's partial vapor pressure in a solution or a mixture is equal or identical to the vapor pressure of pure solvent multiplied by its mole fraction in solution. Mathematically, Rawls law equation is written as P equals to X into P naught, where P is vapor pressure of solution, X is mole fraction of solvent, and P naught is vapor pressure of pure solvent. Next. Let us take an example. A solution of a volatile liquid A and B in a container. Because A and B are both volatile, there would be both particles of A and B in the vapor phase. Hence, the vapor particles of both A and B exert partial pressure, which contributes to the total pressure above solution. Refer to the diagram. Next. Rawls law and its relationship with other law. Rawls law is also quite similar to the ideal gas law. The only exception of Rawls law is that it applies to the solutions. If you have read about the ideal gas law, we know that it assumes the ideal behavior of gas in which the intermolecular force that are present between dissimilar molecules is zero and non-existent. Meanwhile, Rolle's law assumes that the intermolecular forces that exist between different molecules and similar molecules are equal. Rolle's law can also be applied to non-ideal solutions. However, this is done by incorporating several factors where we have to consider the interaction between molecules of different substances. Next, there are some limitations of Rolle's law. The following are they. Rolle's law is apt for describing ideal solutions. However, ideal solutions are hard to find, they are rare. Different chemical components have to be chemically identical and equal. Since many of liquids that are in a mixture do not have the same uniformity in terms of attractive forces, these type of solutions tend to deviate away from the law. Next. So
Thank
thank
you,
you
ma'am.
guys for watching.
Thank you all.